Thank you. Thank you. A lot has happened. So I'm not one of those 18-year-olds, but I had the good fortune to start my company with one of those 18-year-olds, work with a lot of 18-year-olds, and have children, so which is my original entry into all of this. But what I'd like to talk to you about is cloud robotics. And cloud robotics may be a new term to you, maybe not, but I'd like to suggest to you that we are doing something much bigger than drones. We are part of a kind of a once-in-a-lifetime transformation of the world using technology. This is a moment when we are extending the internet out into the physical world. Our drones are, yes, they're flying robots, but they're also sensors in the sky. This is the eyes and ears of the internet. And increasingly, we're going to be using the internet as our brain as well. This notion of a connected device is unique to what we do here. I had the fortune of getting into this business in 2007, the year the iPhone was released. And so as a result, everything we did was oriented around smartphone architectures and inherited everything that smartphones have: connectivity, sensors, incredible Moore's Law pace and processing. But by doing that, we inherited the architecture of the cloud as well. Smartphones are a connected device. The old world, in the aerospace world, they thought of vehicles as being a standalone category with their own intelligence, but we thought of drones as being smartphones with propellers. And as a result, we found ourselves aligned with a sort of a generation-long movement to start to combine the core and the edge, the sensors and the cloud, to extend the internet into the physical world and do something that no single device could do on its own. So the migration went simply like this. If I'd spoken to you in 2013, I would have said, woohoo, we got robots to fly. And it would have been super exciting, and we would have geeked out on Kalman filters and various MEM sensors and things like that, and pathfinding algorithms. That would have been cool. A few years later, I would have come to you and I would have said, I think the radio control conventions are not part of this. I think they're holding us back. These are digital devices, they're computers, they should talk like computers. Let's just go IP, Wi-Fi, whatever, to the phone directly, and then the phone will be our primary controller. And it's less about flying and more about mission planning. Now I come to you and I say, hey, you know what? I was wrong about all of that. The drone, done. The phone, done. The cloud is really where it's at. What are we going to do with the cloud now that we can distribute our compute across these three? We can do compute on board, we can do compute on the ground, and we can do compute in the cloud. In the division of labor, what is the function of the cloud? So when you look at this sort of trend of where we're going, this is, you can sort of see there's these big meta trends, this rise of smartphones, the rise of Linux, the rise of drones. And I list the robot operating system as an example of the rise of these advanced or AI-based robotics platforms, the beginnings of a robotics standards or operating system that can cut across many industries. And we're right at the center of this, and we need to think about being at the center of this. So this is the architecture that we've built our company on, and I think overall we're going to see the entire industry move towards. It is a classic cloud-based architecture where drones can talk to the phone, drones can talk directly to the cloud talks back, clouds talk to clouds, you have analytics in the cloud, you have AI, deep learning, you've got storage, you've got sometimes regulation and compliance. All those things tend to move to the cloud. And in between, you have these messaging layers that are appropriate for every layer. So on board, you do things that are real-time and fast, like sense and avoid. On the phone, you do things that require a human element. So maybe it'd be operator control or operator visualization. And in the cloud, you do things that are computationally or data intensive. And the phone's done at like 1,000 hertz, and the phone is done at like 10 hertz, and the cloud is maybe 1 hertz, depending on how your connection is. But nevertheless, there's a role for all those three. You have this kind of cost, speed, and power chart where you can appropriately distribute your functions across all three if your drones are built around a native cloud architecture. We can talk a little bit more about how we're doing that, but the answer is that's the way the drones are going to go. So one of my other hats is that I lead Drone Code, and Drone Code is this consortium of It's the open source consortium of all the big players. It also includes Parrot and many other manufacturers. Ross is part of this as well. And we just recently decided to be a thing, rather than an organization, a basket of companies with sort of vaguely related things. We're going to be a distro. Like, we're part of the Linux Foundation, and we're going to have a distro like Ubuntu or like Linux. And it's going to have a release schedule, and it's going to have a roadmap, and it's a full stack. And it's going to be based on PX4, which is one of the two projects. This was the one that's got the BSD license, which is more appropriate for companies, as opposed to ArduPilot APM, which had a GPL license, which is great for community participation, but toxic to companies because of risks about IP leakage. So this is what we're doing. We're building this cloud infrastructure. It's got all these layers, the middleware layers, the comms layers, the cloud layers, the mobile layers. And there's an opportunity for companies to just insert themselves at any layer and add something proprietary, exactly like Android, exactly like Linux. And so you'll see the formal announcement of this distro in the next few weeks. But basically, by the end of the year, we expect that 40% of the industry, in other words, almost everybody except for DJI, and possibly Parrot, although Parrot's part of this as well, will be using the drone code stack in one form or another. Very similar to the way the Android iOS split went in the early days. So let's just talk about what this cloud robotics actually means. So this is a little bit of I'm going to unpack this slide a little bit, but basically in robotics, we talk a lot about closing the loop. So closing the loop means having a feedback cycle. Our drones close the loop on board by, you have sensors, you then measure the sensors, you fuse all the sensors, and then you actuate the motors to respond to the sensors. And that's that feedback loop, sensor actuation, sensor motor, sensor motor, sensor motor is how a drone stays in the air. So that's a closed loop. It's called the inner loop. But what's interesting is that when you get out of the inner loop into things like navigation and data, it's not closed anymore. Now it's an open loop system. An open loop system is where you sort of say, hey, do something, and you don't know how it went immediately. It doesn't learn instantaneously and adapt. It's not dynamic, it's static. So mission planning, for example, is all too often an open loop system. Hey, go do this thing. And then it does that thing. And it comes back and you're like, oh, that's not the thing I wanted. I want a better thing. And then you do it again. Well, so the reason we don't close the loop on this second loop, the navigation, the mission loop, is because we don't have the ability to assess the quality of the mission in real time. Now, we're starting to do it in little ways with things like sense and avoid. So sense and avoid, for example, is a way where you're like, hey, go over there. And I go over there, and it's like, oops, there's something in the way. And then you dynamically change the mission to get around that thing. So that's the beginnings of that. But that's really based on safety and not hitting things. What about from a data acquisition perspective? What if I said, hey, scan this table, and I come over here and I scan this table, and I say, hey, now that I'm here, I see the shadows are kind of gnarly down there, it's really quite bright there. I need to sort of adjust the mission as appropriate based on my reading of the data. Well, we don't really have the compute power on board right now to do that appropriately. So what if it then that data gets streamed to the cloud in real time, and rather than the mission determining the data determines the mission. So what I do is I say, scan that table. The drone goes over and it says, okay, I'm just going to take a couple first shots. Just like if you were taking out your phone and you were going to scan the table, you'd take a couple shots, and then those shots would go to the cloud, and the cloud would say, okay, I see what you're trying to do here. I'm going to need you to go over here for your next shot, then I'm going to need you to come over here for the next shot. Exactly the way your phone might guide you to the right shots. And so now the data, the analysis of the data, is dynamically changing the mission. And now, at the end, you're not guessing at what the algorithm wants. The algorithm is telling you what it wants. We've closed the loop. And we've closed the loop by connecting drone and data. A few days ago, Intel had a drone day with the FAA Administrator Huerta and many others, and it was many people in this room were there, and the real message from Intel and everybody else in the room was, it's not about the drone anymore. It's about the data. We now have to think like data companies. We need to think of what the data is good for. How do we analyze it? How do we analyze it faster? How do we know what problems it solves? I know it doesn't sound super sexy because, yes, we got into this because we thought flying robots were cool, but we're now in this world where you hear about AI and deep learning and machine vision, and we're now in big data land, and we have one of the biggest data sets around with some of the biggest unsolved problems. So from a pure Silicon Valley perspective, we are in the most exciting time, in the most exciting place with some of the biggest problems that could transform some of the biggest industries, construction, energy, agriculture, et cetera. But it's going to take real hardcore data science to do it. No more sticks. No more, I love this stuff. But drones are kind of a solved problem by and large. What's not a solved problem is making them useful, going from a toy to a tool. And that's going to require a lot of kind of classic Silicon Valley AI stuff. So this is what cloud AI, cloud robotics looks like. It's closing the loop at the cloud side. So how do we do that? Well, we know that many of these drones can talk to the cloud, but they talk to the cloud the wrong way. It's asynchronously. So what we do is we do the mission, we land, and then I don't know, sometimes you take an SD card out of a camera and put it in a computer like an animal. Sometimes. I'm proud to say with our new site scan product using the Sony camera, it is wirelessly transmitted automatically to the cloud, and I think some other companies like Keswick do the same thing. But that's okay. But anyway, the point is that we're doing it in a batch. After the mission is done, we then geotag all the imagery, we filter it, we send it to the cloud, to some analytics engine, in our case it's Autodesk, and we wait a day. And then at the end of the day, we're like, how'd it go? And sometimes it went great, and we're super happy. And sometimes it went crappy, and we're like, oh, I guess I didn't do the mission right. Or I guess I didn't, I guess I should have looked at the imagery. There was something went wrong, or maybe the shadows were different, and I got to go back and do it again, or accept an inadequate scan or ortho. So that's what happened. That's a kind of an open loop, asynchronous process. And it takes a day to find out. And going back is a bad user experience. What if you could stream? Now, we have the technology to stream to the cloud. By stream, I mean this notion of mini batch. Here's 5 photos at a time. Send the 5 photos back. The algorithm, it can internalize 5 photos and send back a command. Hey, looking good, keep it up. Or, hey, change your camera settings. Or hey, you're going to have to take twice as many or half as many. Or change your angle because of the shadows, et cetera. What if you could start to get that feedback in real time with the stream model? And you're seeing a bunch of stream algorithms out there starting to take over. This is actually not so unrelated from the streaming algorithms that like a Netflix or an Amazon Video might use to stream data down. Which is to say it's designed to handle different kind of connections, it's non-deterministic communications, latency, buffering. This is real-time computer science, but the good news is we're not the only ones solving this. Okay, so then the only missing thing is that the algorithm in the sky, the algorithm in the cloud, has got to be able to handle mini batches. It's got to be handle streams. That means take in data in incomplete sets and come up and start to populate its answer so it can figure out what's missing. And then it needs to be able to translate what it's missing into commands that the drone can understand. And this is another really interesting thing. So Autodesk is our partner. They invested in us, and we work closely with them. But we'll be working with others. We'll be working with everybody out there in the cloud space, the Amazons, the Microsofts, et cetera, the Googles especially, because they're all trying to solve this problem, to get these amazing AI-driven cloud algorithms to start to work on a streaming real-time basis. Are they doing it because I asked nicely? No. Are they doing it because they think drones are super cool? They do, but that's not why. The reason they're doing it is because of cars. By the way, just before I was going to show you this thing. If you want to know what it means to have an algorithm dictate a mission, take up your Android phone and do a spherical shot, to get a spherical shot. And what you'll see is it'll sort of take the first shot, and then it'll tell you where to point. Go, there's a circle, move to the circle, move to the circle. That's exactly what the cloud would be doing to the drone. Move to the circle, move to the circle. Okay, so I'll come back to the cars in a second. But when you start thinking about cloud architectures like this, you don't think about sense and avoid. You think about fence and avoid. What's the difference between sense and avoid? Sense and avoid says, I know nothing, man. I just walked into this room, the lights came on, I can barely see, I'm like groping my way around. Fence and avoid is, I walk into this room, and the first thing I do is I say, hey, has anyone been to this room before? Is there a map? Is there a guide? And you say, okay, get that from the cloud. I was like, oh, got it. Okay, there's these aisles, there's these chairs, et cetera. So I'm just going to use my eyes to focus on any change from the map. Fence and avoid is basically a smart cloud-based solution, which says, gather the best data you have from everything that's happened before, and then start looking around. This is this notion of using the collective maps and even contributing to the collective maps. You can do this notion of real-time render and feedback I just talked about. Even augmented reality benefits from this use of this cloud map. And if you played Pokemon Go, you're using a collective map. You're using cloud data to help you navigate a virtual world. Same concept. So this is where we're starting to see this merger with the car world. Autonomous cars are the hottest things. I wish I could tell you that drones are the hottest things, but autonomous cars are even hotter. And rather than sort of saying, oh, boo, we should have been doing cars instead of drones, instead rejoice, because we're in the same business. We are solving the same problems. We're going to solve it the same way, often with the same companies. So what it's really about is this map. There is going to be this collective map of the world, and it's not going to be like the maps that the old car companies had with like streets and latitude and longitude. This is n-dimensional. Yes, it has streets, but it also has traffic rules. It has traffic patterns. It has things about lighting. It has things about legal policies. It can tell you where the cops are, where the traffic cameras are. It can tell you where the other cars are. It knows the differences between HOV lanes and non-HOV lanes, et cetera. So this n-dimensional map of the real world is something that we're solving on drones, and this is from AirMap. And so AirMap solves it with drones with things like FAA, local and state regulations, ultimately include privacy, operator certification, company rules, et cetera, just layer and layer and layer over the physical world. Think of them as like Pokemon gyms on the physical world. And meanwhile, over in the car space, we've had the Wazes of the world and others start to do the same thing. And now Waze is owned by Google, and now you're starting to see the car world is starting with things like basic streets, street view, then accidents, dynamic traffic patterns, and then all those cars out there with cameras are starting to record the geometry of the space. Hey, here's a sign. It's a stop sign. Everyone else has seen it before as a stop sign. It's been recognized as a stop sign. You don't have to recognize it again. Hey, there's a trash can on the road. Oh, each car saw it. It wasn't there yesterday. A bunch of cars saw it today, so there's confirmation. Tomorrow, it might be gone. So these dynamic things, these are all starting to be built up. And there are companies like Mobileye out there who have 800 people just looking at imagery from cars and classifying it. And this is starting to build up this other map. So we have like the air maps of the world doing the air. We have the Mobileye's and Google's and Tesla's doing the ground. And now we're starting to talk about combining them. And we have the opportunity. If we get it right, this is the opportunity. We could get it wrong, but if we get it right, we're going to realize that we're solving the same problem, and we're going to solve it together. That we are going to collectively, as an industry, the cars and the drones, are going to build this n-dimensional map of the world. And this map of the world is going to be contributed to by millions of entities. Every car will contribute to it. Every drone will contribute to it, automatically. This map will have static and dynamic. This map will be increasingly high resolution. This map is going to be better than any human sense because it knows things that are invisible. This map is going to be the one that lets our drones go out into the world without having to rely entirely on its senses. We have treated our drones as standalone devices for too long. We've thrown lots of sensors at them. We've made them bristle with cameras and LiDAR and radar because we didn't connect them to the cloud. If you connect it to the cloud, we as humans are pitiful things. We as a society are powerful. This notion of social drones, this notion of harnessing the collective, this notion of using the outboard brain of the internet is what makes us so powerful, and it's time for our drones to do the same thing. So if you want to know how Jeff Bezos is going to solve these hard problems of beyond visual line of sight, flying drones to random places, he's going to do it the cloud way, because that's the way Amazon would do it, that's the way Google would do it, and that's the way we're going to do it as well. Thank you very much. Ted, do I have time for questions? Yeah, okay, 5 minutes for questions. Yes, sir. Ma'am, sorry.
Okay, great idea, but what about the bandwidth? How are you going to get the connectivity?
Yeah, great question. So the question was, what about the bandwidth? Again, luckily, this is a problem that's being solved by the car industry, not us. So you probably heard that. So Qualcomm is also an investor in us, and Qualcomm you probably heard is just doing a deal with AT&T to move this to 5G networks. You probably also heard that the Verizons and everybody else, the Deutsche Telekoms, are all working with the car industry to create this cross-carrier mesh of connectivity. So you'll be able to hop from carrier to carrier without, your car will be able to copy, your drone will be able to hop from carrier to carrier. What's interesting about it is that it's not a lot of data that you need. Take the cars, for example. The way they've optimized it now is that the cars download the latest map, and they can do that ahead of time, so you can do it maybe even over Wi-Fi. But as they're traveling, they only upload 10K of data per kilometer. So they're just uploading the delta and deviation. They basically say, yep, everything's fine. Oh, trash can, that's new. So anything that's not on the map that's meaningful, that's what they upload. And so you just transmit change. And so this notion of cloud robotics is being solved by a lot of big companies collectively, and we'll just harness whatever they got. Another question. Yes, sir. Who will control the map? This is a really good question. Who will control the map? Well, so we had a big meeting with the FAA 2 days ago, and the FAA said, not us. and the FAA said, hey, why don't you guys just get together and come up with a standard? And we're like, that never works. Here's what's going to happen. Some companies are just going to do it. And some companies are already doing it. So, for example, Mobileye has a map, and Google has a map, and Tesla has a map. And one of them will be more open than the others. So whoever makes a good map and makes it more open will tend to become the de facto standard. And we will either use their map on the grounds that the auto map is close enough to the drone map that we can just build on it, maybe like an OpenStreetMap model, but bigger. Or maybe one of us drone companies is going to do it. I think AirMap actually is in a pretty good position to be able to do that right now. And so what they'll say is, look, yeah, we built the map, we built it for our purposes, but we're willing to work with others to open APIs, to maybe enhance the map, to let other people add data. And so typically it tends to be a fast leader in the industry, sort of sets a de facto standard, others come on board, then they kind of work as a consortium around that. Yes, sir. Oh, DJI could do it. DJI was also part of this. They use AirMap, like we use AirMap, so they don't have that map themselves. And by the way, I have no interest in owning that map because I don't want to be liable if it's wrong. So DJI and 3DR are kind of aligned around the AirMap model. DJI is in a particularly unique situation because it's a Chinese company. There's some data sovereignty issues, and people are a little uncomfortable about that, but that's geopolitics, and I won't go there. Yes, sir, in the back. Well, I mean, never is the answer. It will never be fully functional. Like everything else, it's going to evolve over time. I think you're going to see dynamic. There were two things I showed you. One of them was using data analysis in the streaming real-time context, and you'll see that by the end of the year, probably from us. The other is this map that we can all tap. And today, you can get it from AirMap at some resolution, but it's not a high enough resolution to avoid, to have things like, here's a tree, here's a building, et cetera. Those are being developed on a kind of a company-by-company basis and not shared. So that's going to be a harder problem. I think that's kind of beyond the same track as the autonomous car map, which is to say 3 to 5 years, maybe? Yes, sir. Yeah.
And that was the issue of security.
Mm.
Now, I can see the vision that you have of thousands of drones, all interconnected through 5G, through the cloud. Hackers are creative. They're going to hack the system, take control of swarms of drones. How's that being addressed?
Yeah, well, again, the advantage of using the cell phone architecture is that you inherit all the security of the cell phone. So what you've just described applies to cell phones. Can hackers take control of thousands of cell phones? Actually, it's relatively hard. In the movies they do, and occasionally in real life they do, but it's relatively hard. If we're using the 5G networks, then again, it's not Wi-Fi, it's the 5G stuff, and that, again, the cell carriers are pretty good at that. So I think that the problem you described is not zero, but it's no worse than the problems we already have for cell phones. And we have, as a result, billion-dollar companies working on it. So let's just assume that it's kind of that order of magnitude. So likewise for cars. Yes, ma'am? How does the aviation industry? Huh. How does the aviation industry fall into that? That is such a good question. By that you mean aerospace industry. I'm going to answer it super honestly. I don't know, because they seem to be absent from this. If you look at the Drone Advisory Committee, there's a few aerospace companies on it, but it's mostly people from this room. If you look at the marketplace, there's very few aerospace companies in it. If you look at the technologies, I mean, they've been mostly focused on the military world, which has completely different standards. There are a couple companies that are starting to be proactive about this. Airbus is a company that we're working with, and you probably saw that today. So we're doing a project with Local Motors and Airbus, and 3DR is doing the avionics on that one. And that one's for their cargo drone challenge. So I think that's a really healthy openness to some of these more open Silicon Valley, like standards. So that's a step in the right direction. As far as the other companies, aerospace companies tend to preserve barriers to entry. They tend to like things that are highly regulated. They tend to fight this sort of stuff. So I'd go to AUVSI and ask them. I think we've run out of time. I'm going to be around all day, so grab me afterwards. Thanks.
Thank you.